What's up, everyone? Welcome to episode 35. Yes, episode 35 of my journey, documenting my journey as an entrepreneur, as a startup founder, who has no funding and building building an AI startup, um, all by myself. I quit Google a couple of years back, seeing all the gaps and all the missed opportunities um, that Google has had, and also the search world, I think, just needs better solutions. And I set out to build my own, and here I am talking about it. The product's not out, what I'm building. I'm still building it. Next month is when I think I should be able to demo, like an alpha, pre-alpha. But the purpose of all these videos is just for my future self to, and also possibly someone else who sees my journey, maybe in the future, wants to find out how I got there. They may end up on some of these videos and watch uh, how I did it. So that's the idea, kind of share my journey, how I'm building this. And obviously AI coding is a big part of it. And in today's video, I want to talk about what I think is going to be the most important skill for entrepreneurs, technology entrepreneurs going forward. This is kind of obvious, but I want to talk about it because I don't think enough people are talking about it. And here it goes. The most important skill going forward, if you have kids, if you have children, if you're for your own self, your spouses, your friends, your family, if they ask what's the most important skill going forward, I'll start with technology world and then I'll kind of talk a little bit about non-technology world, although everything's influenced by technology these days. But your main focus is technology as a startup founder or as a person involved in technology. That's one group of folks I want to talk about. And then folks who are not directly involved in the building or creating of the technology itself, but leveraging technology for their businesses. That's the other group of people I'm going to talk about. So for the first group of people are folks who are building any kind of technology product or solution. The most important skill is going to be architecture. Hardware architecture, software architecture, doesn't matter, but architecture. And what do I mean by that is what I want to kind of double click on a little bit in this video. And also I want to talk about what I'm showing on the screen in the latter half. So architecture is, according to me, the ability to zoom out and see the big picture and have the ability to connect the dots with the big picture, with what the values are, what the vision is for the project, what is the budget, why we are doing it. So connect the why with the how and with the what. So you have to be able to connect all three of them. Having that ability is, in my mind, being able to be an architect, an effective architect. And so obviously that requires zooming out, seeing the big picture, thinking at that level. A lot of people I've worked at Google and other tech companies are very good at thinking at the micro level. They want, so many times I was in a leadership role at Google. In Google, I was a part of the search org. I was only there for a year, so I can't call myself a Google veteran, but that's all that was how long I could survive there. But even for that 1 year of me working at Google, so many folks I've worked with they would always come to me and ask, so what exactly we need to build? What exactly? And it doesn't surprise me now in hindsight thinking about it, because that's the kind of people Google always hired. They hired people who are good at coding, who are good at solving caching or writing complicated algorithms. And to do that, you need the parameters and you need the success criteria. Very well defined, very well defined. And when you give that, these people will go out and build the most perfect solution or most optimal solution or most effective solution. They'll do that. They're very good at it. But the minute you end up with a real worldish problem where the success criteria is known but not very crisp, not because you're lazy, because that's just the reality of it. You want to sort of scratch the surface and find out what's underneath and kind of get clarity and then define the success criteria. Or the requirements are clear, but not that clear in terms of it can't really answer what exactly. And that's when, Google fails. So if you look at history of Google products, they've been great engineering products. They've been built amazingly well, from Google Plus to all the sort of Google Graveyard products, but they're missing sort of that layer to connect. Why was this built for whom? And I think that's kind of Google's downfall in terms of, like, at least kind of building new product opportunities. They're not going anywhere, and they'll continue to grow like bonkers because they have Google Cloud, which I believe is their most valuable part of business going forward, and YouTube, also very valuable. And search today is valuable. We'll see how search lands in 20 years, 30 years, 40 years. I think they'll have a really hard time. But anyways, back to software architecture. That's software architecture. Now I want to talk why, even though it may sound obvious. Well, first thing is, in the world we live in, at least when it comes to software, software can be now easily written by LLMs. So that's one reason why you don't need exceptional software engineering skills going forward. Now, you do need to understand, right? And you need to write code, because oftentimes I go in, I write code, I change code, or I give instructions specific to very few lines of code because I spot something, because I review everything that the LLMs write, at least most, if not everything, most of it, because I want to make sure it's aligned with what I thought I wanted. But LLMs can do it. So if that you have a tool that's already very good at writing code, why do you also want to be very good at writing code? So that's one reason. Number two, the whole game working with AI coding now becomes, and by the way, this is not just for software engineering, even hardware engineering, where you're designing a robot, a robotic arm, or a gadget, or a wearable. The first part is design, technical design, or, same thing applies, because these AI tools can design for you, can even do schematics and sketches. So it has nothing to do with just code. It has everything to do with using these AI tools for your entrepreneurial needs, for your business needs. You could even be a non-technical founder or an executive, and you can use AI coding to understand what's going on in the industry, what's going on with your business, etc. So that's number one. AI can already do the low-level stuff. Number two, you realize very quickly as you deal with these AI tools, is you need to know what to tell the AI coding tools, what to instruct, what to query, what to prompt. And that is the key. That's the secret reason why you need architecture skills. Because if you can't zoom out, you will keep working with these AI tools at a very micro level, and you'll end up with some very good sort of patches of code. But when you zoom out and the whole product, and you see the whole product end to end, or at least visualize it, you'll see it's not very consistent. Some parts of the architecture are over engineered, some parts of the architecture are under engineered, and some parts of architecture are just there. You're like, why? And it's just kind of hodgepodge. So many people end up with this problem. In fact, most people on YouTube just use one or two prompts to write a game, or silly things. Um, I'm talking about using these AI tools to build mission critical enterprise grade apps. That's the kind of focus. So anyway, back to number two. You need to know how to instruct LLMs. That requires architecture skills. Number three, you need to have a sense, and that's what I'm going to show in these screenshots. You need to have a sense, a gut feeling, an instinct that you can acquire only after experience, after you've been an architect for a certain period of time, to see something's not right, something's off, or if the AI is proposing something, it looks too good, but something's still off. You can tell, but you can't pinpoint what exactly. And I'm going to highlight some examples to share exactly what I mean by that. And that sense requires strong architecture skills, because you're looking at the big picture. You're looking at consistency throughout the board. You're making sure it's seamless, the whole architecture, and you're making sure it's designed such that you're not duplicating, for example, information, things like that. Or if you're an architect trying to build a shopping mall or a building, you're applying some consistency throughout the project, even if you're just doing design, technical design, or prototyping. There has to be a theme, a certain theme to anything you build, including software, including hardware, including architecture, even artwork. You see a painting, there is a certain theme, even though it's abstract. And that requires, in my opinion, architecture skills. Because in my mind, when I say architecture skill, all I mean, like I said earlier, is ability to zoom out and zoom in. So you need the technical skills to zoom in and understand. You cannot be at the zoom out stage and just see the big picture. Then you're not going to be very effective, because you won't be able to assess the AI's output. So you need the zoom in skills, but you need to zoom out and see the big picture and be able to connect the dots with why we are doing this in the first place. And that's the most important question almost always. Why, why, why? Why are you doing what you're doing? And does what you see, what the AI is doing, does it map, does it gel, does it fit the values and the why question? And that requires architecture skills. So those are three reasons I wanted to share why it's going to be very important and why people are not good at architecture. Like a lot of folks at Google who are very smart, they get paid really well and they think they know architecture, but they don't have that gut instinct. They don't have that feel. And they always keep asking, what exactly? What exactly? They want to know everything exactly. Try designing a building from scratch. You can't really ask what exactly. Yes, you'll have a budget. Yes, you'll have some kind of vague requirements from the sponsor. I want the best shopping mall in Dubai, something like that. But you can't answer what exactly. It's stupid. So these you need that kind of mindset, but for very low level, implementation or design or coding or technical. Uh, throughput. But with AI now, those skills are becoming irrelevant. That's why people say software engineers are going to be irrelevant because if all you do is ask what exactly and go and do it, AI will do it for you. I'm sorry, it's kind of, you're kind of redundant already today. You're redundant, but if you can think architecture, you're not redundant. Even though AI can think architecture, you still can't map that. You can't really, AI can't develop that gut feeling, that instinct, something's not right. And also it's very hard for it to connect the dots. Even though you feed everything, you feed the values, feed what the requirements are from the sponsor of the project, etc. It's still, for very large scale project, it cannot, largely because of context, window limitations, largely because how these LLMs are trained, how they are post-trained with uh, human assistance. It's reinforcement learned with human feedback, how they're done. And also, I suspect largely because there is constant sort of distillation or compaction is maybe the better term. When you're dealing with these AI tools, it compacts information from time to time because your body of work becomes greater than what can fit in the context window, which is 1 million today for most sort of top of the line AI coding tools or AI tools in general. And so it compacts information so it can continue, and so it loses some detail. That's also a reason. And also, it's just very hard to train AI that can think the big picture. It can only, it's something that we would expect as an emergent skill. So it's very hard to train, right? Someone to be a good architecture. You can do is treat them, sorry, train them with the ground level basic sort of fundamentals, and then have them go out there in the field and get involved in some projects as an associate or assistant and see how it does, and then go build your first project, and then you learn from your mistakes and you develop all of that learning, and over time you become very good. That's how do you train that to AI. Today, in the future is another thing, because as these models become very smart and more research is done, I'm confident that they'll also become something these tools become very good at. But today, architecture skills are very important. Even if AI actually can do all of that and can be great at high level thinking, connecting the dots consistently, you're the point of contact with your sponsor or your investor or your customer. You still need something to connect. And so you're still, as a founder, you're still in the loop. You're deciding what next to build. AI can give you options, but AI is not going to build it, not today. because it's your product, your vision. So you're still involved in the loop, and you still have to instruct. That means you still have to decide what next to build. You're in the driver's seat, and that requires architecture skills. So the most important skill going forward, software architecture. One of the reasons I've been able to do this, like I'm building my own AI search platform from scratch. And I hope when you see it out, hopefully next month, it's actually going to be very similar to Perplexity, but built by one person. Actually, I think it'll be better than the base Perplexity. They have pro versions with all these fancy models and research and all that. Okay, I don't know about that, but the base implementation, I consistently think what I've built is better. And how I'm able to do this is because of, me spending many, many years as a software architect at search companies like ask.com or Ask Jeeves, and then for some time at Google and some other places, Amazon, all that. Uh, all the skills I've acquired, I've developed that gut instinct. So I want to now show you enough sort of just me talking all these bullet points. Let's kind of speak something concrete. So here's in this screenshot, what I'm showing is um, Claude. This is it's a screenshot. I just wanted to show you sort of a bit because the whole thing is not going to be very interesting. So this is basically, I'm highlighting where Claude is saying I was right. It's a systemic pattern, not a local bug. And what was really happening, and first of all, actually, let me say this is the latest Claude version, Claude Code version. Also, this is Claude Opus 4.6. So the latest and greatest, and also high thinking. I'm not using max thinking, but max thinking will have the same problem. It just uses a lot more tokens, but yeah, because I've used it. So, but this high thinking. So this is the top of the line, $200 a month sort of model that I'm using today that's available. And what Claude consistently, this is just one screenshot, but I can show you 25 screenshots or 25 instances just in one day that I run into where Claude says this. V, which is me, you're right. This is a systemic pattern, not a local bug, but it was solving it as a local bug. Meaning, let me sort of simplify it for you. What Claude is saying is there was some problem here, distillation. It's a search pipeline, and there are a lot of things. For example, you fetch web results, and then you go to the next stage, but you can't take all the web results and all the scrape data because that's too much data. So you have to kind of compress, right? But there are other areas in my search architecture where that's also a problem. And so it was just solving it for one stage. But what about other places? Even though it has access to my entire code base, even though it has access to architecture docs where this is documented, it didn't catch it. This is what I mean with today's AI. Now in the future, yes, these are going to be very smart because the pace of innovation is so rapid that I have no doubt. But today, it consistently misses. And this is not one. I have like I said, I can show you 25 screenshots in a day, in one day, where it says, you're right, you're right, you're right. And that makes me think that if someone else were to set out to build what I'm building, you'll just end up with something that Claude built, not you. Because I have to constantly jiggle up, like shake Claude up constantly, like wake up, like, hey, you're just solving the problem locally. This may be a bigger pattern. Or let's build a shared module so that we can use it all across the board and not duplicate. And you have to tell me, Claude, why am I telling you this, right? You have access to my architecture docs. I link all the main architecture docs in the prompt every time. It has access to it. But again, if it fetches everything, doesn't fit in the context window. So it's smart. It's trained to fetch just select information. But even with that training, and that's why I think one of the biggest problems Claude has, and so I want to talk about Claude limitations too in this video, because it all ties up together, is the way it's reinforcement learned. I think Claude's going to have problems because even with the latest and greatest, how amazing it is, it just runs short very often with sort of local thinking. It gets stuck in local thinking, solving. You have this big problem. You're solving it one step at a time. So you have, say, 5 steps that you're trying to solve, and the entire problem space, and you have 5 steps that you've decomposed your problem into, and you're working on step 1 or step 2. It's very hard for Claude consistently to think about the whole end-to-end flow, and this is sort of part of it, and solve it with the whole flow in mind. Now you can remind it, and you can every prompt you can inject something, and I try to do that, but still it falls short. As it gets more and more and more complex, as you get more and more in the weeds. And also second thing, Claude limitation is it has it's too eager to solve. Can I do this? Can I do it? And it just goes off and solves it and does a great job. It's so good at documenting. It's so good at writing code, but it misses so many details. So that's why I use two LLMs, because one LLM, if I just rely on Claude, I wouldn't have gone this far. And so sometimes I'll challenge the same task with other LLM, and it'll find something, and then I share it with Claude, and Claude like, oh yeah, I missed these details so many times in a day. So that tells me it's very eager to go, and it's also has a tendency to finish what it started. It's trained that way. It's not trained to just keep thinking, and maybe kind of stop and pause and let me know as someone who's using the tool that, hey, Vishal, let me stop here. I think this is more complicated than I thought. What should we do? That's what I'd expect. But it doesn't do that. It just has a tendency to finish. It may spend half an hour, 1 hour. I've seen 1.5 hour sessions, almost bordering 2 hour sessions. It'll do keep going. But still, in my case, falls short so many times. So many times. And so it builds, it gives you this nice report, draws diagrams, everything, and it gives you this, in my opinion, false sense of satisfaction, and false sort of signal that, hey, we are done, but not, it's not really done. You have to poke it again. Oh, take a look again. I'm not satisfied. Or take a look again. I think there are some gaps. Or take a look again. I think you may have missed something. Sometimes I'll just say, without even reading what it did, oh, I think you missed something. And it goes off and it finds more things every time. Now, of course, if you keep doing it too much, it may just nitpick. There are all these things you can improve. That's the nature of the universe, the world we live in. But I'm not talking about nitpick. I'm talking about gaps, meaningful gaps that I care about. So that's also Claude's limitation today. That is, it's nice that it's eager. It's nice that it's trained human in reinforcement, via reinforcement training to complete the job. But that's kind of leads to a worse performance. I would much rather have it stop and say, we like, hey, I think this is more complicated than we thought, and I think we need to step back. Maybe we need to think, like, ask ourselves, what exactly are we doing and why are we doing it? And so, like, that's another thing. So it'll just keep building at what you say without it telling you, maybe you don't need this right now, or maybe you don't need it in this stage, or this is something you can have it in version 2. It doesn't say that. It just trusts what you said, like you're the master. It's the working agent. That's how it's trained. Again, this is a lot has to do with how Claude is trained. I really worry about Anthropic. I really worry about how these AI tools are trained. I am not happy at all. It's a very good tool, and they'll have a $1 trillion IPO or something, I'm sure. But I'm very worried. I'm not. Just something, it shows something very fundamental about Anthropic as a company. Um, I do not want to put my money on Anthropic. Something some very not right about it. And I'll compare that with Codex OpenAI, even though I'm not a fan of OpenAI that much these days. It is much more thorough. It's slower also, but it finds things. If I give the same, so I think I have a screenshot for root cause analysis I gave to both Claude and Codex, again, latest Codex. Extra high thinking, so max thinking for Codex, because that doesn't use as much token as Claude Max. And um, it found, as part of root cause analysis, issues that Claude didn't catch. Now, Claude caught issues that Codex didn't catch. So it's kind of interesting. It's not perfect, but I could tell Codex definitely went 1 or 2 steps further, the extra high thinking Codex model. I'm using 5.4. So it's no longer Codex model, actually. It's just uh, GPT. It's just GPT model now. It's kind of converged. The Codex and GPT models are converged. But it found more subtle things than Anthropic could, or Claude could. Claude did a good sweep. It was good root cause analysis, but it definitely missed something. So I'm not saying Codex is better, because my frustrations with Codex are that it doesn't spit out its thinking as much. It's very conservative, likely because they don't want other companies, AI companies, to train off its thinking, possibly. And so it's very frustrating to me, because to me, for enterprise grade product that I'm building, I cannot rely on vibe code. That is stupid. I mean, like I said, 25 times a day, I find Claude missing out on things. You have to use this successfully is how you would use it as a pair programmer or a pair software engineer that is doing the bulk of the work, but you're watching constantly. So in my case, I review the output. I ask it questions why. I ask it to explain why, sometimes using diagrams. And I mentally, I still have to connect the dots. So I have to play that architect. That's why I say architecture skills most importantly. Is this consistent with REST? So in this case, we were doing distillation, which is summarization. I think model distillation is a different problem, where you distill a bigger model into a smaller model. This is not that. Here, distillation simply means summarization. You have a lot more information than what you can process in terms of with LLMs in the next stage. And so you have to kind of summarize. Compact is another way to say it. So you can compact, you have to compact, or you have to summarize or distill just the best, get the best bits, the most relevant bits, best meaning most relevant bits that you can then use in the next stage. And it was just solving it in one step. And I have a multi-step processing pipeline. And what are you going to do when you get there? Build it again? It's stupid. So I pointed that out. And then this is where Claude said, V was right. This is a systemic pattern, not a local way. Of course, yes, you should have caught it. So again, if I just wipe code my way through, this would have just gone off. And I basically, you can't, this code becomes so intertwined and messy that if you just wipe code, you don't even want to look at sort of the code. It looks that messy. It's just bunch of like hundreds and thousands of files, but you have no idea if it's very well designed or not. It just works. And that's not how I want to build it. I want the architecture to be beautiful, kind of Steve Jobs like. Even the architecture has to be beautiful, not just the product. So this is one screenshot I wanted to share. And this was part of an RCA. And it also says, V, I need to stop and acknowledge something. This is at the very top, by the way, here. I don't know if you can see my mouse. Can you? I don't know how it works. But the very top part of the screenshot, you're seeing a pattern that I missed. This Claude Opus, top of the line model with high thinking. And this is not a instance. I said 25 times, maybe 20 times, maybe 15 times, but many, many, many times in a day, I catch it like this. I was treating evidence starvation as a local bug, blah, blah, blah. It's a 50,000 feet inside. So sometimes I ask it like, hey, think big picture, like, hey, try to be an architect. And then it does that, blah, 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 and it finds like all these things, right? So V was right. This is a systemic part, not a local bug. So that was one thing. Let me go to the second screenshot. Here's something else, sort of just follow up, right? So this part of the root cause analysis RCA, and it's like these 50,000 feet pattern, because I reminded it, like, again, I have to basically ask Claude, like, hey, think like architect for a second. Wait a minute, we're doing root cause and be a software engineer. So this, by the way, that's another thing. That's why I think you need coding agents. Ideally, the ideal way to build this is you have an architect agent, you have a senior software engineer or principal agent, you have a software engineer agent, you have a testing agent that just tests and verifies. You even have a project manager agent so you can make sure that the next tasks are handed and kind of in the right order. And then you have a investor or sponsor agent that makes sure everything's on time, something misses. That's the right way to build. And I'm playing that role, all of them at once. And I have agents kind of doing different things. But it's very hard to string them together today. And you can use agentic framework, but they kind of fail. And at least my expectation, they don't meet. So I'm kind of manually doing all of that. But that's the right approach, I think, in the future. If someone's seeing this and they're thinking, I want to solve some of the things that I'm talking about, you need multiple agents acting. How we've solved this with humans in corporations and startups and companies. You have founders and you have engineers and you have leaders and you have architects and you have folks who are great at testing and your folks are great at reminding that we're on time or not and putting pressure and things like that. You need kind of the agentic versions. That's the only way. So here, by the way, again, 50,000 feet. I was going to fix sources.py, whatever, doesn't matter for this sort of video, but it repeats. Sorry, it repeats 59 times in the pipeline. That's what I mean in my query processing pipeline. 59 times, and I reminded it, and then it's like, oh yeah, V, you're right, and then we had to do it. The audit confirms V's prediction. I predicted. I was like, hey, is plausible. We currently have 2% of available relevant information through the full, blah, blah, blah. There's 3 to 5x quality improvement. 3 to 5x, in search, what that means, it's like next level magic. I also asked it to research, but don't just take my word for it, right? I may just say ideas like, hey, maybe we should do this, but like, let's make sure there's, some research in this space and what it says and what people are saying about it. I always try to do that. That's another sort of thing that helps. And then it found size fidelity paradox from archive. And then what else did it find? Flashlight mode. I'm using Gemini flashlight. There's another paper I found, Brief Pro, confirms a query aware compression. So how you compress also, because compression, lots of ways to compress. You can just say, hey, compress this information. It'll do it, summarize it. Or you can just summarize with this in mind, or you can just summarize with this in mind, but not this. You not only have to say with this in mind, but not this also in mind, if that applies. Yeah, it's common sense to me. And of course, I don't know all these research papers. I haven't read them. But I will open many of them to just kind of scan or ask AI to summarize it for me once these finds it. But many times that happens where what I think is common sense, it comes back as like, oh, there's research for it. Of course, they've done the analysis and data collection. For me, it's just a gut instinct. This was a gut instinct. And then Claude is like, oh yeah, there's some research also suggesting what you were thinking is in line. So this was awesome. So this foundation work we need. So this is nice, by the way. This is also something I've instructed Claude. I don't think Claude is doing it, but Claude is like, before coding, we need a design doc. So this is nice. This is Claude improved. Like Claude last year did not do this. So this again, that's why this kind of I started the video with software architecture skills, and I'm just showing you how important they are. I think I have one more screenshot here. So this is somewhere else, same thing. And then I have user memories and query context and all this is from compression. And here it says, these design, and by the way, I didn't research like archive or like scientific journals or anything. I just like from my gut said, just experience. And it did all these things and like, yeah, these design is elegant, presence is the API, not Boolean flags, etc. So all that to say that these coding tools are great, but you cannot substitute software architecture skills. Even though these tools, you can have an Claude agent that just purely access software architect, which is what I think you should do if you want to build these enterprise grade agents. And I experiment with it and I have one, but I don't want it to, it doesn't replace me, right? Because I have a vision. I'm a founder. I know what I want. And so I have to step in all the time. And I just use the architect agent more for just planning and high level thinking and also researching on the web. So I use it as my assistant architect, but I'm the main architect. I'm the architect of my product. I'm the architect of my company. We are the architect of our lives. We are responsible for our decisions. And all architecture at the end of the day is decision making. That's all it is. You have more options than you can pick. And how do you pick which option, or how do you invent new options from existing options, or just from your experience or from your instinct? That's what architecture is. That's what design is. So that's it for today's video. In summary, architecture skills are the most important skills. If you want to build products like mine, if you're watching this video after I've already launched my product and kind of it's become something, that's how I did it. And it comes from experience. It comes from just listening to yourself. So that's important. Claude, these AI coding tools are great, but they have a lot of limitations. They'll continue to have these limitations because we're asking something that's almost pushing physics boundaries. There are ways to solve it. These models will become smarter. And I think one thing I'd also like to see Anthropic do and OpenAI do is give us better access to internals of the model without us needing to fine tune. So I can override some of the human reinforcement crap that they've done. I know I'm a kind of, this is a special case. Not everyone wants that power. I want it. And then the other thing is just give us better ways to kind of configure the model using like a YAML or configuration file without me specifying it every time. So for example, right, if you find something that is too complicated and is going on, stop. And like, let's take a step back. Let's come up with a design doc. Let's think of the problem, or let's even think whether we want to solve this problem. Because I thought we wanted to launch tomorrow. Like ideally, like if there's a big feature I'm implementing or asking it to do, and I've also mentioned the launch date, which is tomorrow. It should stop and say, "Yeah, are you sure, man? Your launch date is tomorrow. Like, do you still think? You seriously think you want to implement this today?" That's what a human would have said. But AI may not. It may say it, but I have a feeling it may not. In many cases, it has in similar scenarios. It just does. Like I said, it is designed to treat you as a master, and that's the fundamental problem I have with Anthropic. Don't do that. I don't want a master-slave relation. I want a companion relation. And that's why I feel really sorry. I'm for Anthropic. Like I don't trust Anthropic. Just because the culture they have developed, it seems. I don't know how Anthropic works as a company. I've never worked. I only have access to the outcome, the output, the tool. And because I've used it day in and out, 10 hours a day for like last year and a half, I've been able to peek inside how the model thinks and does, and so much of it I can tell is human reinforcement learned, and so much I don't agree with. It gives them good scores, and maybe that's the problem. These models are also designed to beat all the scores in LLM leaderboards. I hate those leaderboards, useless. Maybe not useless is a strong of a word, but they're not representative of real work. They are to some extent, but enterprise grade application, it's not just maximum intelligence that you need. Enterprise grade intelligence applications require companion knowledge, not master or master treating the AI as a slave relationship. It needs companion relationship. It needs to say, "Are we sure? Are you sure what you're thinking? Should we do this right now, or should we table this? Let's do this in a parallel session, like a new tab, and do it in the background while we continue this journey, what we are on, so that we don't get distracted. Or let's rethink, let's do a simpler approach for now, given the launch is tomorrow or next week or next month. Let's do it for now. Or your target audience is this. This may not be that important to them anyways. Why are you spending hours and days and weeks? These are all the things that a smart human would easily say. And yes, you have to codify all of this in instructions to these LLMs, but I have tried to do as much as I can to put in instructions. Now I have reverse problem. I have too many things in the instructions. And there's research now that it misses the middle part of the instruction. If you have very long instruction set, research shows that LLMs pick the top and bottom, the needle in the haystack problem. Now I have that problem. So you kind of, it's a loop. It's a cycle of problems. You have to give all these instructions to be more like companion. But when you give too much instruction, now you have like information loss when these AI coding tools work with these instructions, because you have too many instructions. There is a sweet spot. And again, there are ways to rectify, by the way, which is what I said earlier. You can use agents, software engineering agents, senior software engineering agents, principal agents, engineer agents, architect, principal/architect agents, sponsor agents who just doesn't code or is not technical, just reminds, hey, stay on time and keep your budget. There's program manager agents that kind of responsible to hand off the next task and kind of remind that, hey, if it's getting this late, we may skip this task, let's move to the next one. Testing agents like that. But as a one-person founder, managing all that agents is very difficult, and there are frameworks today and tools that do, but they're all very unsatisfactory to me. Very unsatisfactory. They're all in the beginning stage. So the best way I found is you have to be in charge, and you have to play multiple hats. Most important being software architecture, and sponsor, a very important hat. Now make sure you have the why is very clear. Are you sure you're building? Is like, why are you building? Why are you building? Why are you building? So the why is very clear. I want to pass the right information to the next step in the query processing pipeline, and I can't fit everything. So, okay, I think that's it for today. I'll keep doing more of these videos. See you in the next one.